Okay, so today I'm teaching Adam, Drew, and Carter bridge transformations and case. Bridge transformations of like y to delta and delta to y, things like that. And so this right here is pretty much all you need to know when talking about y to delta and delta to y transformations. And so we're going to go through this is a y, and this is a delta. So we're going to change this to a delta and change this to a y. And so I'm going to change colors. So when we go from a y to a delta, right, this is a y, we're going to go to a delta. We're gonna visualize this picture and then use these equations. So that point right there is at y. That point down there is my z. And that point right there is my x. Right? And so the ending picture. And so this is my RB. This is my RC, and this is my RA. Right? Here's my R2, here's my R3, here's my R1. And so since we're going from the letters, right, to the numbers, we're gonna use this equation. Does that make sense? Because we're gonna find R1, R2, and R3. That's what we need. That's what these are. So okay, so we're gonna start with RB. So, or I guess let's start with R1. That'll be easier. R1 is defined as this equation, right? So I'm gonna explain it. The numerator is all the different combinations of the letters, right? These three letters multiply the sum of those products. That doesn't really make any sense. The A times B plus B, A times C plus B times C. You see that? You see how that? I mean, it's this times this plus this times this plus this times this. And then the denominator is just the one across from it.
Okay.
Right? So if we put R2 here, the numerator would be the same, and the denominator would be RC. That's the memory.
R3, it would be RA.
Correct.
Would be the denominator.
Correct. And so we're going to start with R1. R1 is going to be RA times.
So you could flip each one of them.
We're going
Then add that together.
So since the numerator is the same every time, we're just going to calculate the numerator quick. So RA.
So G is equal
6
to
times
R is equal to
4 plus
and so when you see a plane,
6
6
times.
times 5
6 millisieverts
plus 4 times 5.
1/6.
Right, so that's our numerator for every single one of these. R1 is going to be 74 over its opposite. 4.
Yes, so we're basically collapsing. Let me give you some equations here. All right.
That's how you convert from a Y to a delta.
Alright.
Now, to convert from a delta to a Y, it's this kind of sort of the same thing. You have the same, there's a memory link, right, for the equations, but when we're going to the letters, we want to use this equation. So the denominator this time is going to be the same every time. It's just the sum of all the numbers. And the numerator is just going to be the product of the two resistors next to it, around it, surrounding it. So we'll start with RA. Here. We'll find RA first. RA is, which one's the same? Numerator or denominator? Every time. Denominator, right. Which is different than when you go from letters to numbers. So RA is going to be, so let's calculate the denominator. Since it's going to be the same every time, let's calculate it. The sum of all these numbers.
Be 5 plus, what's the bottom one? 6, 5.
Right, so that's the denominator. So RA is going to be R1 times R2 over that number we just calculated.
RB.
The numerator is the product of the things surrounding it.
So 2
So for
adjacent
A-
ones to it.
Right. For A, it's R1 and R2.
For B, it'd be
For
2
B, it's
and
going to be
3.
2 and 3. And for C, it's going to be 1 and 3.
Alright.
I'm evil, just leave it.
So RB,
Do what you can.
we're going to take R2 over R3.
I have no idea.
Sorry, R2 times R3 is going to be the numerator.
But you're right. that
So,
R3 was what we were
2 and 3.
So 6 over 11.
Right. Is going to be 1 and 3. So 1 is
Okay.
6 and 3 is 3. So that's converting y's to deltas and deltas to y's. Okay, so we just got done. That was y to delta and delta to y. This right here is a bridge because of its resistor in the middle. Because these two deltas are sharing this resistor in the middle. That's what makes it a bridge. And we're gonna use the qualities that we just learned in the first video, in the first half of the video, to
I'm just trying to figure out what kind of kid.
to an actual problem. And so what we're going to try to do here, our final answer is going to be 1 voltage source, a battery, and 1
We
resistor.
just need 5 for each of them.
Yeah, so do we need 5 subtopics?
This is 24 volts.
You need.
And so we just need to combine all these resistors into that one. So, okay.
There could be 1 repeat. So you could be 2 pieces.
In this specific problem, we only have to change a delta into a y, and we're gonna do the top one.
Like,
So
basically.
okay, so this is our y, this is our z, this is our x. Those 3 dots. Right, and so when we change it into from the delta to the y, we're gonna make this our y, this is our z, this is our x. That's what it's gonna look like. These 3 are gonna go to these 3, and those 2 are gonna stay the same.
What would I do with the 2 right there?
So they're each gonna be 2 ohms, alright? And we need to figure out what these 3 are gonna be.
So these are resistances.
So-
700, you just go to 10. And then you do. Okay, so you can't do all.
Remember, try to picture this picture.
Because
We're gonna
the two
go
is sitting in the
from
It's not
numbers to
parallel.
letters.
Right, so you
So we
do
need to
plus three,
use this
that takes
equation.
care of that one. Then you do the 10 and the 15 in parallel.
Right?
Yeah.
So
Yeah.
just those two.
Yeah. And so the numerator is gonna be
1 over 15
the,
plus 1 over 10
is gonna be dependent
plus 1
on
over
whichever this is, and the denominator is gonna be the same.
that
So the
many.
denominator in this case is gonna be 6 plus 6
The
plus
10
6.
and the 15 are parallel,
Oh.
right?
So that's 18.
It gets parallel eventually. So once
So,
this is combined, so
RA,
this is, call it equal to 1 over RA. So
it's gonna
now,
be
this whole
a 1 times by
combination
2
R,
Oh.
and that
36
combination
times
is
6
series with the 10.
over 18.
Right, so we're gonna add 2 to the R, and then
Yeah,
that
just-
combination
so
is
2.
in parallel.
So what is it,
So this one,
And then that thing is in parallel with 2.
okay.
So we sort of go back and forth.
RB, right here, is gonna be 2, R2 times R3 over 18. R2
Which one are you?
times
I was
R3,
looking at them to like,
right?
know which ones go together and what I had to write down in here. That's okay, you can take them away.
That was RB.
I wasn't copying it.
Okay, I'm sorry.
And then RC. 6 times 6 over 18. So it just so happens that all of our resistors are 2 ohms now. But do you guys understand how I got those 2s?
Yeah.
Okay. Okay, so all I did here was I rearranged stuff. This X is right here,
So this is, so you.
this
do
Z
and found
is right here,
what?
and this Y is right here.
Okay.
You guys see how I rearranged that?
So 6 then is the
And
combination.
here you can obviously see that these are series, these are series.
Over the answer.
And once they combine, they'll be parallel with each other.
And we add 6.
And then you can, once you combine those parallels, it's in another series.
As we go forward.
So, first things first, we're just gonna add these 2 together and add those 2 together to combine them into one, because they're in a series. Okay, so I just combined those 2, combined these 3 into those 2 different resistors. Now they're in parallel because they share the same nodes on top and bottom. And so, in order to combine 2 parallel resistors, take the inverse of both of
1
them,
over 8 plus 1 over 20.
add them together,
Equals 1 over 2.
So like this will be
Right.
2 things for A.
And that's
then 2 things for B.
1 over RT,
And then,
which means RT, the total resistance, is 2, if you combine them together. Okay, so I just rewrote it again. This is that 2, it didn't change. And then these 2 4s combined in to make this 2.
Give me 1 second.
And so now they're in series, and all I have to do is add them together. So our final answer right here is 4 ohms. So that's how you convert a bridge, something like this, into a simple system that has just one resistor.